Okay. Is the screen visible?
Not yet.
Not yet. Now?
No, sir.
Still not.
No, not.
Oh, what happened? Now?
Yeah.
So now it is visible.
Now it is visible. Okay. Okay. So, oh, sorry for a bit of delay. So we have these discussions on use of probability in NLP, machine learning, AI every 15 days. So today I thought that in the beginning we'll discuss a bit about what I saw in CERN, where I had gone for this Sparks conference. It's more of brainstorming and free flow discussions, which happened for 2 days, 17th and 18th September. But while reading the slides, I thought there is quite a lot of material, and maybe we'll not find time for the discussions on probability. So let me concentrate on what I saw in Sparks, which is centered on what is happening in the field of AI and where it is going to in the future. All right. So like Sparks, I also want this particular presentation to be quite informal and free-flowing. You will see that we will not go into any kind of mathematical details or rigor. What is important is the intuition and some of the emerging realities and directions in AI, which will occupy human endeavor for quite some time. I'll also spend some time on CERN as such, which is the European Center for Nuclear Science Research. Now, since the discussion is free-flowing, do feel free to butt in any time. Okay, do make your comments, ask questions, interject. I would welcome it very much. So this can be more like a brainstorming session. Now, let me at the outset itself put before you the highlight of the discussions that took place. I see on the chat box a message from Ankush. Is there any connection problem? Okay, no. You're able to hear me, see my slides?
Yes, sir.
Yes, okay. Okay, so one of the central concerns, I think the most important concern was AGI, which is Artificial General Intelligence, also called more technically in machine learning, zero-shot learning, which is founded on approximation and adaptation. I'll talk more about it. But let's note this term AGI, Artificial General Intelligence. The AI community is really quite obsessed with Artificial General Intelligence. To put in simple terms, a system that does natural language processing should also try to do computer vision. A system that does computer vision should do robotics, for example. Am I still audible? Screen is visible. I do see some chat box messages.
Yes. Yes, sir.
Yes, sir. You are.
Yes,
You're
sir.
visible and audible.
Okay, okay. So this is Artificial General Intelligence. And if we dive deep down into a particular area, for example, natural language processing, a system that does machine translation should also be able to do sentiment analysis and question answering. So this is, of course, inspired by whatever we see around us. Animals display general intelligence. Okay, a dog can sniff any kind of problematic situation. A dog can eat, it can smell. We also are very multi-purpose intelligent entities. Now, AGI was probably the central theme of all these discussions. Then there were discussions on what are the missing blocks in AI. Of course, the work on AI started since 1960s. Turing himself was concerned with the foundations of intelligent machine, and named Turing test goes back to 1960s. Now AI has seen ups and downs. There have been winters and summers of AI. So what are the missing blocks? After 40, 50, 60 years, one would like to introspect and see in the field what succeeded, what failed, what is present, what is missing. So a very important insight is this. I think I mentioned this to some of my students. Machine learning algorithms always, invariably, do some kind of optimization. They optimize an objective function, and that is done by minimizing a loss function. Okay, all of you who are working in AI will agree with me. Key point: humans do not work with an objective function to be optimized, but AI systems have to. So do please ponder on this very fundamental point, where the objective function, the loss function are not known a priori. And this definitely has bearing on the question of artificial general intelligence. You may say that for zero-shot learning, general purpose intelligence, if I say that the loss function is not same, you might come back and say, no, we use total sum square loss or cross entropy loss. That is true. But the parameters inside the loss function, the variables and the expressions that are used, they differ from problem to problem. So, so there is this key point to be reflected on. Human beings do not work with an objective function to be optimized. If any of you have any discussion points on this, I would welcome it as we go forward. AI and creativity. AI and creativity, models to break out of the rut. Okay, I'm looking at chat box comments. We'll take them up a little later. AI and creativity. So creativity is a hallmark of intelligence, and AI and creativity are very intimately linked. In fact, there was a breakout session completely devoted to curiosity and creativity. Creativity requires breaking out of the rut, and there was a breakout session on breaking out of the rut. And in fact, breaking out of the rut is a favorite topic of mine also. I have attended many sessions in the past on this kind of brainstorming on AI. And invariably in all of them, I have said that we have to create models of AI which get bored. We have to mimic boredom. We have to simulate boredom. The phenomenon of boredom needs to be modeled. A very important concern for AI now is ethics, governance, and AI risks. So there was a very insightful short presentation on why AI systems could be potentially dangerous, because these are not holistic systems. Human beings are sensitive to environmental concerns. So the point that was made is that if the sound level, temperature level increase, decrease, go below or above a threshold, then our living and even our survival may get endangered. Okay. On the other hand, AI systems may not be sensitive to temperature fluctuations. Then there was this question, what if AI succeeds? Many of you are possibly familiar with the celebrated AI textbook written by Stuart Russell and Norvig. So Russell spoke on what if AI succeeds, okay? And he drew our attention to this question, which was asked by Alan Turing himself back in 1960s. You can imagine the kind of visionary Alan Turing was. So many points which he mentioned for the risks involved in a situation where a machine becomes intelligent are valid today too. Now, is reconstruction of personalities and behavior prediction possible from ML and social network footprint? So a company of Europe actually demonstrated reconstruction of personality from social media footprint of that particular person. Of course, the individual also revealed a lot of personal information which was not open. And then AI for science is really a big thing. Caltech, which is a cradle of physics, I should say, Professor Anima Anand Kumar came from Caltech, and she is focusing deeply into AI for science, how AI can be used for science. Now here I would like to make a remark based on my understanding. What is the connection between AI and science? Why? the basic point here is science, especially physics, is an exact science, okay? Quote unquote exact. So you have a concrete formula, E equal to mc square, F equal to force into mass into acceleration. These are quote unquote exact formulations. AI, on the other hand, is founded on approximate decision making, approximate reasoning. So where do these two disciplines meet? Well, the notion of exactness in science is an illusion, okay, which was shown by relativity, quantum mechanics. It is an illusion, okay, and the instrument of quantum mechanics is probability. Now the story goes that Einstein once said, when quantum mechanics was pushing the frontier of physics, Einstein once said that he didn't have much belief in quantum mechanics. He said, God doesn't play dice with the universe. And Niels Bohr, who was one of the forerunners of quantum mechanics, rebutted, saying, God can play dice if he wants to. Okay. So why dice? Because dice, throw, coin tossing, these are very popular devices in probability to illustrate our understanding of probability and the methods of probability. So scientific knowledge needs a vehicle for expression. It needs a formula, for example, a mathematical formula. If a formula is not possible, then it needs a procedure, a step-by-step procedure to do something. If neither of these two possibilities exist, then you have to give an expression which has to be inexact, founded on probability. So scientific discoveries from data have to be approximate using AI technique. That is the connection. Okay. And one of the success stories in recent times of AI for science is AlphaFold from DeepMind, a subsidiary of Google, if I'm not wrong, which predicts protein folding very, very accurately, beating all the research groups across the world. And this is purely based on power of data and machine learning. So these were the main, main topics which preoccupied the participants in future of AI. So summarizing the keywords: artificial general intelligence, missing blocks of AI and creativity, ethics, governance and AI risks, what if AI succeeds, reconstruction of personalities, and AI for science. I do see quite a few comments on the chat box, but let me proceed and then we'll come back to those points. Now, CERN is a big thing. It's a very prestigious place. And there was this news item that I had gone to CERN to participate in the Future Intelligence Conference. And the news was that I had gone there, and the event took place on September 18 and 19, 2021 at Geneva. And there were several other eminent people who attended the workshop, some of whose names appear here on the slide. Professor Anima Anand Kumar from Caltech, Josha Bach, VP Research for AI Foundation, Stuart Russell virtually, Jürgen Schmiduber later, after 18th actually. Some of the big names in AI. Now, what is Spark? Spark is a serendipity forum. What is serendipity? I'll talk about it a little later. Now, CERN being what it is, okay, it's a big prestigious institution with huge amount of funding, which sees every day, top people visit the institute, give talks, interact with people. It is appropriate that it also takes interest in AI, which is changing the face of the world profoundly. Okay, so how can CERN be, at the back seat, not taking any interest in what is happening around it? So AI is a big thing. Okay, for absence of other appropriate words, CERN is also a big thing. So it is quite natural that CERN organized this event to discuss the future of AI. The event was called Future Intelligence, and the emphasis was on future. Okay, not exactly the state of the art, but where is the field going? Now, the name CERN comes from, I do not have correct French pronunciation, but this is Conseil Européen pour la Recherche Nucléaire. So here you can do a bit of NLP and see that Conseil Européen is European Council. So in French, the adjective always goes after the noun. So Council is council, but a more appropriate translation is organization. So European organization. Pour is for, la is the research nuclear research. Okay. So again, inversion of adjective noun. So what does CERN concern itself with? Absolutely the fundamental questions of life. What is the nature of our universe? And what is it made of? So particle physics is the main subject or discipline of CERN. I did not see a lot of biology, chemistry, huge amount of physics, computer science and IT, and of course, enormous amount of engineering. Okay, because there are these particle colliders, accelerators. This is a marvel of engineering, which you cannot guess until you go into one of those tunnels which are underground and see the operation of cooler, motor, transformer, and so on. It's an engineering marvel, of course. But this engineering is for a very deep purpose to understand the nature of universe and what it is made of. What are the particles? Can we create new particles? The institute is also very, very concerned with how the whole creation started. The Big Bang theory. What happened after 10 to the power minus 10 to the power minus 10 seconds? Okay, these are the concerns which are discussed in the institute all the time. The mission of CERN provide a unique range of particle accelerator facilities that enable research at the forefront of human knowledge. So we would like to note these phrases: particle accelerator, then perform world-class research in fundamental physics. Okay, the research there is of fundamental nature, not much applied. Okay, new materials can get created, but that is a byproduct of investigating fundamental questions. An important mission of the institute is also to unite people from all over the world to push the frontiers of science and technology for the benefit of all. So benefit of all is a phrase to be noted again, because there is no guaranteed funding without social impact. I mean, I'm not really contradicting myself when I say that application is not really the main concern. The main concern still remains very fundamental questions of creation, questions of what the universe is made of, and so on. But as a byproduct, indeed, a lot of useful applications get generated. And particle accelerator, why particle accelerator? Particles are accelerated close to the speed of light. I think those of you who take interest in physics know that there is an upper limit on what speed an entity can attain. Einstein had proved it. And that shows the immense intellect that Einstein had. Nothing at all can cross the speed of light. Okay, there is an upper limit. So the particles are taken very, very close to apparently 98% of the speed of light. Okay, and at that speed, phenomena happen at nano micro scale, okay, very, very small scale. And one of the tenets of physics, one of the wonders of physics is that physics says if we understand the micro, we can understand the macro also. Okay, there is similarity of methodology and findings and knowledge for the micro world and the macro world. So what happens in the universe, astronomy, for example, this investigation can get help from understanding particle physics. And the research is supposed to be absolutely world-class. No compromise on the standard, of course. Now, what is particle accelerator? It propels charged particles such as protons or electrons at high speed, close to the speed of light. So we're doing some physics here because the event happened at CERN. And all of us know that it is physics which gave us the framework for any kind of scientific inquiry. So those particles are then smashed either onto a target or against other particles circulating in the opposite direction. And by studying these collisions, physicists are able to probe the world of infinitesimally small. Okay? So that is a concern. And why such people would be interested in AI is something we should keep in mind and see if that gets answered. Now, some of the key achievements of CERN, which is really the pilgrimage for physicists. The Large Hadron Collider is an engineering marvel and also possibly the most sophisticated instrument for physics. And I'd like to mention this again, that the fact that, such extremely sophisticated instruments and such engineering marvels exist, you do not guess it by being in the campus of CERN. Okay? It is like any other campus. Antimatter was discovered in CERN, and I have something interesting to mention about antimatter. When Big Bang happened, matter and antimatter both got created. Okay, and the property of matter and antimatter is that when they come together, both of them get annihilated, and energy is produced. Now, one of the mysteries which puzzles physicists is that why is it, though antimatter and matter got created, why matter remained while antimatter progressively diminished and almost vanished, but antimatter still exists. So when matter and antimatter come in each other's proximity, energy gets generated. So why this preference of the scheme of things to matter and not antimatter? Okay, so this is a fundamental question which engages the mind of top-level physicists. Web was born in CERN. Internet was born in CERN. Okay, from a cluster of some 5-6 machines, people started, exchanging information over 5 or 6 machines, and that was the seed of what we see as internet today. It was born in CERN. And the Higgs boson, which is also known as God's particle, was one of the big news items in 2012. And 2013 Nobel Prize also was in the news because the discoverers of Higgs boson were not given the 2013 Nobel Prize. I think they got it later. So there was quite an uproar about why such deserving people have been ignored for 2013 Nobel Prize. So there have been a number of key achievements of CERN. So physicists and engineers at CERN use the world's largest and most complex scientific instruments to study the basic constituents of matter, the fundamental particles. So as I mentioned many times before, this is definitely an engineering marvel: mechanical engineering, civil engineering, electrical engineering. And now, since there is such a big amount of data, now the computer scientists and IT professionals have a big role to play. Subatomic particles are made to collide together at close to the speed of light. And this process gives us clues about how the particles interact and provides insight into the fundamental laws of nature. And CERN says they want to advance the boundaries of human knowledge by delving into smallest building blocks of the universe. So these complex and very valuable and very large scientific instruments is indeed a dream for experimentalists. Okay, so experimental scientists look forward to spending some time in CERN so that they can make use of these facilities. And these instruments used in CERN are purpose-built particle accelerators and detectors. Here is some physics coming in. I have taken it down from my notes as well as from Wikipedia, just to emphasize how detailed and complex the work is. Accelerators boost beams of particles to high energies before the beams are made to collide with each other and with stationary targets. Detectors observe and record the results of these collisions This is where big data and AI begins. Detectors observe and record the results of these collisions. It was founded in 1954, and half of CERN is in France, the other half is in Switzerland, in Geneva. And it was one of Europe's first joint ventures and now has 23 member states. India has the status of what is called associate member. Okay? The key members, of course, are many of the first world countries like Germany, France, Italy, USA, and England, and so on. Now, Webb was born in CERN, so I went to the place where this placard is displayed, where the Webb was born. In fact, very close to this place, there is a meeting room where we had one of our breakout sessions on curiosity and creativity. Very interestingly, there is this dancing posture of Shiva, the Natraj, which you possibly cannot read it. This was gifted to CERN by Department of Atomic Energy, Government of India. Okay, it is very prominently displayed. It is between the CERN guest house and the CERN hostel, visitor hostel. CERN visitor hostel and the reception of CERN visitor hostel. So this is a beautiful dancing posture of Shiva, which is kept between two buildings. Now, an interesting conversation I had with one of the CERN employees is that there were some protests by people outside CERN as to why Nataraj Murti is kept there in CERN. So they said that this is a symbol. Lord Shiva is the god of destruction. So is it being suggested that CERN actually works with things which can lead to the destruction of the world? So there were tweets by people from outside CERN questioning and criticizing the placement of this symbol, okay, this Murti of Shiva in CERN. That is by way of an interesting conversation I had. Am I still audible and the screen is visible?
Yes, sir.
Yes, sir.
Now, this is known as the globe, which is also a symbol of CERN. And that is where we had a number of sessions during the conference, especially the public event, where a number of short presentations were made on the future of AI, and I'll describe them towards the end of the talk. So this is in the shape of a globe. There is a nice meeting room inside the globe. I mentioned the particle collider, the accelerator. I believe there are 6 such accelerators, and the one which is open to public, a lot of visitors come to CERN every day, and this is an important source of earning for CERN. This is known as Atlas. So it is a proton cyclotron. I don't understand all these terms very well. Super proton synchrotron, sorry, not synchrotron, cyclotron, synchrotron. And the full name is a toroidal LHC apparatus. So this is the largest general purpose particle detector experiment at the Large Hadron Collider, a particle accelerator at CERN. And this is me, and we went to 80 meters underground. Okay, and all these facilities are for accelerating particles, observing their behavior. The oxygen level is monitored continuously. If the oxygen level falls below 80% of what should be normal, the human beings do not detect this fall in oxygen level, but there are sophisticated instruments which immediately raise an alarm. So this was about CERN, and since the concern of the institute is to ask fundamental questions, and since there are fundamental questions in AI as well, therefore there is very big time interest in CERN on what is happening in AI. So therefore, they took this initiative of organizing Sparks, which they call the Serendipity Forum. Sparking the future of artificial intelligence, CERN hosts the first edition of Sparks, which is where we were all invited, some 50 scientists and engineers and sociologists, political scientists, environmentalists, all of them were invited to this forum. And it was really a very, very multidisciplinary gathering. And we know that cross-fertilization of ideas happens this way, from the meeting of minds of people from diverse backgrounds. Now, serendipity is the key word here. If we look at the dictionary meaning of serendipity, serendipity is a noun. There is no other part of speech for serendipity. The occurrence and development of events by chance in a happy or beneficial way. That is the meaning of serendipity. A fortunate stroke of serendipity is an example phrase. Now, one of the best known examples of serendipity is the discovery of penicillin, which actually changed the face of the world. So serendipity in science, penicillin, discovered by Alexander Fleming. It was discovered in 1928 and is now the most widely used antibiotic in the world. Penicillin is the most widely used antibiotic in the world. So Fleming is reported as saying, one sometimes finds what one is not looking for. When I woke up just after dawn on September 28, 1928, I certainly didn't plan to revolutionize all medicine by discovering the world's first antibiotic or bacteria killer. But I guess that was exactly what I did. So the discovery of penicillin is often cited as an example of happy chance. Okay. And this was apparently a white mold which formed without Fleming expecting it. And the Wikipedia also says that Fleming was known to be a sloppy biologist. He was not very methodical, systematic, would be sloppy in his work. But this serendipity was waiting for him to happen. So this is what serendipity is, and we have serendipity happening in our life all the time. Another example which is also given is that suppose we are giving our, maybe I'm giving my shirt for laundry and I discover suddenly, let's say 100 rupees in the pocket of the shirt. That is also serendipity. And serendipity by definition is a situation of happiness and benefit. It must lead to some beneficial situation. So the image associated with Spark, which discussed future of AI, the first edition is this image. You can see AI written on top of a chip, okay, hardware chip. There was a public event on the 2nd of Sparks where many of these very leading personalities in AI spoke. And this was on a stage, and it was conducted by Bruno. I don't remember the full name. He is well known for conducting these TED Talks. So he was there. So let me now give a little more details about the event itself. It was a 2-day multidisciplinary science innovation forum and public event. So this multidisciplinarity was the characteristic of this event, and we should really appreciate multidisciplinarity, diversity. Okay, really, a lot of new thinking comes from interaction of disciplines. Okay, while one should be rigorous and one should go deep into one's own specialization and discipline, one should always keep the eyes and mind open for new ideas to come from another discipline. And I could see it because I often had to change my expressions language when I was talking to, for example, an artist or a neuroscientist. I remember I asked a question on complexity of an algorithm, and I was using NP completeness, NP hardness, those terms. And the person listening to me asked me to explain these terms. What do you mean by NP completeness, NP hardness, and so on? So you have to sometimes forget very area-specific terminology and paraphrase them. Okay, once you paraphrase, it is not difficult to understand. Language has that power. So the event was divided into two parts, the forum and the public event. Participants from around the world joined the forum, both virtually and in person, with the aim of sparking, that is the genesis of the name, sparking informal and spontaneous conversations about the topic of AI, deviating away from traditional conference formats. Okay, so the free-flowing nature was the hallmark of the event. The forum consisted of group discussions around 6 key themes, from ethics to creativity. Participants were engaged in collaborative discussions throughout the day to identify and explore questions arising from the advent of AI. And the questions which engaged the mind of people and were the cornerstones of the discussions were, can identifying the potential of AI become an existential risk to society? Okay, can AI become an existential risk? Okay, can it wipe out humanity, for example? What would the world look like if we had to share it with human-like robots? A very key question. And I didn't know that so many people and people of such keen intellect are engaged on discussing this point. How the world will be if we share it with human-like robots. Could mapping of our brain help us develop better AI? This is the strong AI stand, strong AI hypothesis. And the possibility of an AI winning the Nobel Prize was also discussed. So now I'll go into presentations in the public forum. After that, we can take up the points made in the chat box. I can see a large number of them. Presentations in public forum. So I have these slides numbered as 1, 2, 3 because I could not find an appropriate title for this because these presentations had very diverse landscape. So first speaker was Daniel Kahneman. He was an economics Nobel Prize winner. Nobel Prize winning author of Thinking Fast and Slow. That's a very famous book, right? Thinking Fast and Slow. And the co-author of Nudge, a revolutionary exploration of why people make bad judgments. Because there is a tenet of rationality which says that human beings always try to be rational. You always try to ensure personal gains. Okay, so for example, in going from place A to place B, we would normally choose the shortest path, which will save fuel, save money, save time. So we make rational decisions which optimize something. So the book explored why people make bad judgments, what goes behind it, and how to make better judgments. So this particular book is full of novel insights, rigorous evidence, engaging writing, and practical applications. Here I would like to digress a bit and tell you what economists do. I have heard a number of lectures by very celebrated economists, including Amartya Sen. And they seem to have one kind of template for their lecture. Sorry for using a mundane term, maybe template. I see that they start with a hypothesis, which all scientists do, by the way. And economists thrive in statistics and data and numbers. Talks by economists invariably have slides and slides of tables, pie charts, bar charts, and so on. So they take some human concern and establish this by data. Economists, in that sense, are epitomes of data science. The amount of data Amartya Sen collected for his investigations into economics of poverty was humongous. I've heard this from him when he gave talks. So economics as a discipline thrives on data, really. So this particular book also, he said, Professor Daniel Kahneman, these are from my notes, okay, the notes that I took when I heard these presentations, said that it is full of, the Adam Grant, who reviewed this book, said full of novel insights, rigorous evidence, say this phrase, engaging writing and practical application. Rigorous evidence is something we as AI scientists and engineers also should aim for. He introduced the term called noise in decision, different voices, and he introduced this interesting phrase called decision hygiene, decision health. And the reason why people make bad decisions is because of disharmony. This is what I heard him say. In a family, for example, why wrong decisions will be made when the family members are in disharmony. Okay, and that leads to noise in decision. Now, this is pertinent to AI. Okay, why was such talk given a place in discussions on future of AI? Decisions made by AI agents can be noisy. Okay, and can we borrow ideas and instruments from economics to solve problems of decision making in AI? There was one person, one individual only in the history of Nobel Prize and Turing Award so far, Herbert Simons from Carnegie Mellon University, who got both Turing Award and Nobel Prize. Turing Award is the highest award in computer science. Nobel Prize, of course, all of us know. And he was an economist. So he showed how the theory of rationality can be used to make create mechanical intelligence. Am I still audible and the slides are visible?
Yes, sir.
Yes, sir.
Yes, sir.
Then there was a talk by Professor Anima Anandakumar. She, by the way, is an IIT Madras alumnus. And she talked mainly about AI for science, and more specifically, AI for partial differential equations. Okay, so I really need to delve deeper into this, how AI could be used for partial differential equations. Then AI for quantum chemistry, and she mentioned graph neural networks for her work. Okay, so graph neural network was the technique she was extensively using. And the big picture is AI for science. Okay, the specific problem is AI for partial differential equation. The technique used is graph neural networks, and the big picture is AI for science. And then I had a personal conversation with her for some time. And I was talking about the traveling salesman problem, for example. Traveling salesman problem is known to be NP hard. Getting exact solution for traveling salesman problem would demand exponential amount of computing time or resource if we use parallel computation, for example. Therefore, we have to settle with good approximation to the exact tour of the traveling salesman. Now, I was wondering if approximation and adaptability is the cornerstone of AI, then what is new about it? You know, after all, randomized and probabilistic algorithms have been doing it all the time. So the point she made was that no, the key lies in zero-shot generalization. So you adapt the solution of a problem, the solution that is given for one problem A, to problem B. Okay, so this zero-shot generalization and adaptation is going to be the hallmark of future artificial intelligence. And there is also a practical need for it. I mean, we all know, those of us who work on AI, where do you get huge amount of data, which is demanded by neural networks? Data is in short supply, and this is going to be the reality. If I want to build a sentiment analyzer for Mizo language, where will I find annotated data for Mizo language? I may not be able to invest resource also. So the artificial general intelligence idea has to kick in, and we have to adapt the solution from one problem to another. Okay, from one language to another language is a small concern compared to this big picture. Adapt the solution for machine translation to sentiment analysis. Adapt the solution for NLP to computer vision. Okay, so that is going to be an important direction. Let us take note of this. Then this person from Turkey, Koray Kavoklu, I'm not attempting to pronounce this. Koray, first name is Koray. He is VP of Research at DeepMind. And one of the big success stories of DeepMind now is AlphaFold. Earlier, you would recall it came into limelight because of its AlphaGo work, okay, which beat human beings in the game of Go. And those ideas and systems have been adapted to the protein folding problem. By the way, protein folding is an annual competition since 1970s, if I'm not wrong. So for last 30-40 years, it has been going on. And research groups are measured against this particular competition, protein folding competition. Chemistry research groups, very famous chemistry research groups all over the world participate in this competition. And AlphaFold, which came from DeepMind, beat all of them in the competition purely based on the power of data and machine learning. Two other problems he mentioned was Met Office, which should predict the weather even at the granularity of minute-to-minute basis. Okay, who needs this? Apparently, the aviation industry needs this. Agricultural industry needs this. May not be a minute-to-minute, but day-to-day prediction of weather is important. And this has to deal with huge amount of data. And there was also the mention of plasma control, which pertains to physics. And that is again something which DeepMind is engaged in. So three problems: protein folding, AlphaFold is a big success story, predicting rain, working with Met Office, and plasma control. These are the three things he mentioned. John Tallinn was another speaker, who is the creator of Skype. John Tallinn is an Estonian computer programmer and investor known for his participation in the development of Skype and file sharing application Fast Track or Kaza. John Tallinn is concerned with the downside of AI, dangers of AI in short term and long term. Short-term dangers are already in view for us. Face recognition, for example, and bias in the data. These are short-term downsides of AI. Face recognition can be mishandled. Okay, one can manipulate the data for evil purposes. Long-term long-term downside of AI would be sharing the earth with machines that do not care for the environment. He mentioned this. If temperature rises by 5 degrees, we feel uncomfortable. And if it continues for a long time, our survival can get threatened. But machines will not have this kind of AI sensitivity. Therefore, since environment doesn't affect them, they can take decisions which can be harmful for the environment. This was an important point which made everybody think about the dangers of AI, and that is not really too far-fetched. It is not an imaginary situation. So, so the downside of AI can be divided into short-term and long-term. There was this presentation by Anja Kaspersen. Anja Kaspersen is a famous person in Europe. Anja Kaspersen is a senior fellow at Carnegie Council for Ethics in International Affairs. She is concerned with AI and ethics. And she was possibly the person who spoke the most throughout the whole event. She is the former director of the United Nations Office for Disarmament Affairs at Geneva and Deputy Secretary General of the Conference on Disarmament. So she discoursed on who holds power. She is from humanities and social sciences. If I'm not mistaken, political science is her background. And AI can have unintended consequences. We do not have control on those consequences. And they can bring quite a huge harm in the operations of our society. So who holds the power? It is not only the question of machine and man holding power. It is also people who become powerful because they have AI systems at their disposal. And they are powerful because they have data to create AI models. Okay, and this kind of have and have not situation with respect to data and AI can be dangerous for the world. Stuart Russell discussed what if AGI succeeds, artificial general intelligence. Turing had touched upon this subject back in 60s, and he was the one who opened our eyes to this particular issue, that in AI we optimize an objective function and not so in life. I was thinking when a child grows and eventually becomes a doctor, let's say, does the child really have an objective function he or she optimizes? Did they know of a loss function which they have to minimize? So that also tends to make you somewhat philosophical. After all, we try to minimize pain and maximize pleasure. We try to minimize loss, maximize gain. So this is at the heart of most of our activities. Does it translate to an a priori loss function? Is the key question. This is the overall picture, but what is the exact form of the function we optimize? Nobody knows this. Hiroshi Ishiguro, he became famous for something. This is written here: the man who made a copy of himself. He actually showed a picture where he is sitting beside his own clone. So Hiroshi Ishiguro is the director of the Intelligent Robotics Laboratory, part of the Department of Systems Innovation in the Graduate School of Engineering Science at Osaka University in Japan. Japan, you would recall, introduced 5th generation computer in the world. This was in 1980s when we were students, and this was such an excitement all over the world. America became very apprehensive. A book was written called The 5th Generation Computer. Countries started their 5th generation activity on AI. In India, there were 5 centers of excellence on AI, one on natural language processing, one on computer vision, one on robotics. This happened back in 80s. We were students at the time. And I remember, participating in all AI conferences in the country and later abroad also, which used to be called KBCS, Knowledge-Based Computer Systems in India. We are trying to revive this again, a general purpose AI conference in India. So, so Japan actually had triggered big excitement in AI in the 80s. Now, question is why it did not go far? Okay, as a historian of AI, as an observer of AI, one would wonder. So, did not go far because at the time data was not available. Okay, and AI was very model driven. People would sit down, think about a problem, and create rules. But this was a slow process and brittle process. Okay, today's success of AI is mainly because of data. And we know that this combination of data and rule is the future of AI. So the man who made a copy of himself, Hiroshi Ishiguro is the director of Intelligent Robotics Laboratory, part of the Department of Systems Innovation in the Graduate School of Engineering Sciences in Osaka University, Japan. By the way, Japan is very strong in robots, especially micro-robotics, which do surgery, microsurgery. The man who made a copy of himself. Moonshots program is a well-known program in AI again. You can do Google search and Moonshots program. MD Anderson's Moonshots program is an unprecedented comprehensive assault to significantly reduce cancer deaths and transform cancer care. Moonshot teams pursue innovative projects prioritized for greatest patient impact, including clinical trial of new cancer immunotherapies, targeted therapies, and combinations. So, Moonshot program has a very noble goal. Simply stated, it wants to reduce the expenditure of cancer by predicting cancer very, very early. Okay, it will take data, individuals' data, and predict that after 20 years you're likely to get cancer. Take care of this right now, then this will save a lot of money, a lot of pain. A very noble goal. And Hiroshi Ishiguro is part of that program, and he showed a copy of himself during that public presentation. Luisa Damiano, Professor Damiano, a PhD in epistemology of complex system. Epistemology means a study of knowledge. So knowledge, if you take knowledge as an entity, what constitutes knowledge? What are the ingredients of knowledge? When do we say an entity is knowledge? And when an entity is not knowledge? You know, these are the questions that engage epistemologists. He is Associate Professor of Logic and Philosophy of Science at the University of Messina in Italy, where she coordinates a research group at Epistemology of the Sciences of Artificial. So she spoke on social robotics. Her research area is social robotics, along with her husband, who was also present there. So she mentioned robot lawyers, for example, and other things. So she also has a lot of concern with synthetic ethics. But what caught my attention is these robot lawyers, because we ourselves are engaged in information extraction from judicial documents. Jalai is working on predicting the judgment from evidences, facts, and figures. Okay. Jalai is an MTech 2 student. So, so these robotic lawyers are going to be important. I mean, AI for judicial domain is going to be important. It is already important, and it is going to thrive in future. Max Welling is a Dutch computer scientist and in machine learning at the University of Amsterdam, who is also with MSR. So he spoke on what happens next. The search engines and recommendation systems will become knowledge graph and deep learning driven. So students who are present here and who are working on knowledge, combination of knowledge graph and deep learning, note this. Okay, the machine learning community is emphasizing the need for domain knowledge to be integrated into machine learning models. This is a reality happening here. And Google search engine is using knowledge graph. Can you imagine this? Okay, is a facility which should respond in less than 1 second is actually harnessing a knowledge graph also, in addition to the information retrieval technology like inverted index and ranking algorithms and so on. So if Raj is here in the meeting, please note this, that knowledge graph and deep learning are being used by Google for its search engine. Details have to be known, of course. The future areas are, this is what Max Welling mentioned. You will note that we are working on some of these. For example, speech-to-speech machine translation. He mentioned this at least thrice. Image understanding, we are in our lab working on image captioning, for example. Abhishek is looking at it. Protein folding, self-driving cars, dexterous robots. Dexterous robots he mentioned. This again caught my ear. Intelligent chip design, AI in agriculture. So these are the future areas which are going to be hugely important. Okay, and we already know speech-to-speech machine translation is needed in the country, and we are an important part of Government of India's Mission Mode project. And according to him, AI is not so much of a danger as is climate change. Climate is changing drastically. The melting, and apparently by 2050, many cities on the sea coast would get submerged. So that was his point. And then Vittorio Loreto from Sapienza University in Italy. This is the oldest university in Rome. He is a creativity researcher. He is with Sony Corporation, and his research focus is creativity. AI can help to be more creative. And this phrase again caught my ear, adjacent possible. This apparently is the source of creativity, according to him. Adjacent possible. So you take a table and from table construct a new kind of furniture by applying the principle of adjacent possibility. That means change some feature to an extent and create a new entity out of this. So a lot of creativity happens by this means, by exploiting adjacent possibility. Then augmented creativity, co-creativity in text and music. He talked about them. Co-creativity is human-machine synergy. Okay, we know already that a lot of music has become computerized, and we have seen, we ourselves in the lab are working on automatic generation of movie script, for example. We worked on automatic essay grading. Some of you also explored automatic essay generation. Okay, so co-creativity is something we are quite familiar with in our civil lab. And also augmented creativity, augmentation done by the machine. Machine increases the capability of the creator. There was a very pinpointed presentation by Eng Lim Go, the Vice President and Chief Technology Officer of High Performance Computing and AI in HP Labs in Korea. So his main point was the following, and this is very, very useful. Let us note this. I am audible? Screen is visible?
Yes, sir.
Yes, sir.
Yeah. So his point was data is siloed, and there are lots of organizational concerns and benefits involved, which is why organizations do not want to share data. Okay, data cannot be shared, but the machine learning model can be shared. In fact, I also broached this topic with Ministry of IT of our country a few days back. It may not be easy to obtain data from organizations, but they may be willing to share the models, and machine learning models from different organizations can be put together. A central server will take all these machine learning models, give feedback, and ask for changing of parameters locally through more data. So don't share data, but don't share the machine learning model. So swarm learning, federated learning, And he also used this slogan, robots of the world unite. So robots might one day say that let us unite and fight against humans, for example. He is also concerned with the dangers of AI. Now, how will this sharing, integration of machine learning models from different sources happen? He mentioned this. I need to understand that blockchain and AI need to combine. Okay, maybe a seminar can be done by one of you on combination of blockchain and AI. How to combine these two? Okay, so I need to understand this. Maybe some of you should help me in that. Then there was this presentation by Hiraoki Kitano. Hiraoki Kitano is a Japanese scientist again. He is the head of Systems Biology Institute, president and CEO of Sony Computer Science Laboratories. Oh, yeah, Vittorio was Sony, and this guy is also from Sony. Sony Computer Science Laboratories. Can AI ask questions? Okay. And he proposes, or maybe it is proposed by somebody else. He mentioned Nobel Turing Challenge. Can AI win Nobel Prize? And then the question is that if an AI agent wins the Nobel Prize, who should take the money? The creator of the AI agent, maybe? So another point he mentioned was that Nobel Prize goes to those pieces of work which have scientific value and social value both, not one of them, not not just one of them. It is a combination. The combination is scientific value and social value. Both have to combine. And systems biology for AI is an important emerging area where biological observations should benefit AI. Again, I'm often tempted to talk about our own work in the lab. Aditya is here in the meeting, and Aditya would recall how we got inspired by the notion of incongruity to design algorithms for sarcasm. So this was, of course, a brain matter, a neurocognitive matter, but actual physical biology, anatomy, for example, okay, botany, zoology, they also will contribute to AI when we create, especially systems which are founded on the principle of strong AI. There was, again, a powerful, a strong articulation by Vivian Ming. Vivian Ming is an American theoretical neuroscientist and artificial intelligence expert. She was named as one of the BBC 100 Women of 2017. So she talked about how AI can improve general intelligence, which people will work best in a team, used NLP and image processing to study wage gap between male and female. Intense mining can discover bases. That is what is her stand. The data science, when really made powerful, sophisticated, and precise, it can discover a lot of biases in our life and society. And for this, you don't have to, get into argument and get into legal battles, etc., etc. Just observe data and process data. So used extensively NLP and image processing. And there was this interesting allied question. She is also a creativity researcher. And creativity happens through interaction of people in a team many times. So this is a managerial question. Which people will work best in a team? How do you force that synergy? Ed Boyden, who is a professor at MIT, American neuroscientist at MIT, he is a proponent of strong AI, that means simulate brain. And when we look at brain as a mechanism, it has amazing space and time management. In brain, 100 billion neurons in humans and 1 billion in mouse. So humans have the largest number of neurons, he said. And the space and time management within the brain, within this small cavity, is a marvel of nature. Matthew Liao is a philosopher interested in a wide range of issues, including ethics, epistemology, metaphysics, moral psychology, and bioethics. He is the director of the Center for Bioethics and affiliated professor at New York University. So he is a strong AI camp person. US Brain Initiative is Google on US Brain Initiative. I think this started in the time of Obama, along with gene mapping, if I'm not mistaken. And he's a proponent of gradual substitution, replace carbon with inorganic matter, that is silicon, say. And I have put down a small note on White House Brain Initiative, brain research to advancing innovative neurotechnologies. Is a collaborative public-private research initiative announced by the Obama administration on April 2, 2013, with the goal of supporting the development and application of innovative technologies that can create a dynamic understanding of brain function. So, so strong AI is indeed the concern of brain initiative. Understand brain and replicate process of brain in a computer. Hans block was the last presentation and arguably the most interesting one. This I mentioned to a number of people, including some of you from the students. Reconstruct a person from online data. That is his concern. Hans Bloch is a German theater director, filmmaker, and musician. He studied music, drums, at the University of Arts in Berlin and theater directing at Ernst Busch Academy of Dramatic Arts in Berlin. His research, together with Maurice Rizwick, about freedom of expression in the age of social media, brought them international attention. So, can your data tell you who you really are? Facebook can predict your behavior. Made to measure online. Made to measure, you Google on this. This is also a project. So his company took data from 100 plus volunteers, and only volunteer number DS25 was selected. Also, only Google data was taken. Only the Gmail data apparently was taken. Private things like height, fears, disease, etc. These data also were taken, and a personality was constructed based on this data. And then an actress was hired to act that personality. And the actress and the original person met, and he showed on the video the conversation between the actual person and conversation between the original person and the actress who acted the personality. And the experiment had to be stopped because the actress complained of losing her own personality. Okay, she apparently was entering into the personality of another individual, and that raised ethical questions. So Hans Bloch also remarked that free and open world is crumbling. Made to measure that online is something you should see. And they made an actress, and there was this intriguing experiment which I have already mentioned. Now I'd like to go into the breakout sessions, which were really intense, and I was in 2 of them. So the brainstorming questions were the following: difference between real intelligence and artificial intelligence. It is quite difficult to, pinpoint exactly the elements of real intelligence and artificial intelligence. The missing links of AI need investigation. And do we even want human level AI? Why not have agents which will do the mundane chore jobs, and we do higher level investigations thinking? Governance and rules and regulations so that AI can be used ethically. This was another question. And there was this question on difference between curiosity and creativity. So the first breakout session that I went to, people were distributed in different breakout sessions. So since I was in the public discussion, since I talked about boredom, modeling of boredom, they asked me, they moved me from one breakout session, some other breakout session, to this breakout session on breaking out of the rut. The discussions turned to self-consciousness, since that is a precondition for breaking out of the rut. First, you have to detect that you are in a rut. That is self-consciousness question. And then this particular breakout session also concerned itself with the question of, do we really want human level AI? Why do we need self-awareness? And the reason why we want self-awareness. There was an interesting answer given by one of the persons there. This had Max Welling, who is from Amsterdam. There was also a Chinese researcher from Facebook. She made interesting remarks on modeling of self-awareness. And we want self-awareness so that we can spot similarity with another human being. Just think about this point. How do I know that me and another human being share some common properties? And myself and a cat, we have some common properties, but huge number of different properties. How am I aware of that? I am aware of that because of self-awareness. So artificial consciousness, somebody mentioned in the group, quite interestingly, that artificial consciousness is already there. The internet is the artificially conscious entity. For example, I have heard people say that I have this question in mind, let me ask internet. So are you not already anthropomorphizing the internet? You're already attributing, imparting human qualities to internet. Let me ask the internet. So artificial consciousness is already there. That's what they said. This is in the internet. And the question was, are dialogue systems needed for consciousness? Do conscious entities need to be engaged in dialogues? Okay. If the brain is in coma, is it conscious? Intelligence seems to have two parts, communication and self-awareness. This was one of the conclusions of the breakout session. Intelligence consists of communication and self-awareness. More points: data-driven and model-driven AI, explorations to create AI. This was also discussed because there were some discussions on history of AI. And I tried to pointed out that RAT is an internal state, and the individual has to see that a state keeps on recurring, keeps on repeating. And the breaking out of RAT happens either by this introspective success, that a state is coming back again and again, or because of resource constraint, imposed constraint. For example, the time is up, let's say. So a meeting which is not going anywhere gets ended after, let's say, 1 or 2 hours because there is a time limit imposed. The other point was that human beings create AI either by their own model, own theory of what is intelligence, or by data which is created by humans. Okay, notice this important point. If the AI model is created from data, that data is coming from humans. And if the AI is model driven, created from the understanding of the human being, again it is coming from human. So whether it is data driven or model driven AI, it is human beings who create it. But then this Facebook researchers said that it is still possible to have a third possibility. This is because of randomization or unintended consequences. So this was a useful breakout session. Afternoon session, which I went to, was curiosity and creativity. So notice the difference between curiosity and creativity, which the group established. Curiosity is an internal state and creativity is a process. Let me repeat this point. Curiosity is an internal state, creativity is a process. It was pointed out that creativity is a high entropy situation. You need disorder to be creative. To break out of rut, you need to introduce noise into the system. You need to shake the system out of its local minimum. That is breaking out of the rut. So when exploitation begins, entropy drops. So during exploration, we are in a state of high entropy, and exploitation of the results coming from exploration requires systematicity, organized behavior, okay, and a step-by-step process. This drops the entropy. So entropy is not always bad. It is important for creativity. Entropy is bad when creativity is exploited to create something useful. There is a book on why greatness cannot be planned. Interesting point about minority reward. I don't know if you have heard this term. Minority reward is when you get the award if majority is wrong and you are right. There have been such competitions organized by AI communities, philosophy communities also, that you get the award if the majority is wrong and you are right. So just having the maximum score is not enough. Okay, you should be the only one who has made the right decision, and majority of the others have made wrong decision. Then only you get the minority reward. So one remembers the example of Galileo, who against everybody's stand say that no, it is the Earth which goes around the sun. The counter heliocentric view of the world. Okay, the sun doesn't go around the Earth, Earth goes around the sun, and he would get the minority reward, right? Because the whole world believed that it is sun which goes around the Earth. Interesting observation which was made in the group is that Nobel Prize winners have a lot of breadth. Okay, did you know this? They go deep into something, but they are enriched by ideas from a broad perspective. And this came out from many people in the creativity group. They are actually creativity researchers. So I have to believe them. They have spent their time investigating this phenomenon. And child prodigies often don't go to win Nobel Prize. Interesting point. Because they become very specialized, and they have less breadth. I made a mistake there. So this enrichment, cross-fertilization of ideas, which is required for any kind of game-changing work, paradigm-changing activity. Apparently, child prodigies cannot do this, okay, unless a more mature person takes them out of that frozen situation. And then I have also made some remark. It was required of every participant. So I talked about the correspondence between exploration, exploitation, which is so famous in reinforcement learning, with curiosity, creativity. Curiosity is exploration, creativity is exploitation, maybe. And two kinds of creativity, curiosity-driven and utility-driven. Creativity happens in two circumstances, when it is curiosity-driven and when it is utility-driven. Engineering creativity is often utility-driven. And this Freudian framework of psychology, which distinguishes between id, ego, and superego. Id is the pleasure principle. Creativity happens when we are in a state of id, okay? And there is a kind of joy associated with the situation and we become creative. Superego is the critic, okay? So superego and id do not go together because creativity and criticism, critic and creativity do not go together, though both are very important, both are needed. And evaluation of creativity happens to critic. And ego is a very interesting state, which means a sense of self-awareness. So Freudian's framework was a revolution in 19th century, considered one of the greatest intellects of humanity. Karl Marx, Freud, I think they coexisted. Their times coincided. Everything boils down to studying the creation of the creator and peeping into creator's design. Today, the attention is shifting to studying the phenomenon of intelligence, just like the 16th century attention was devoted to studying God's physical world. So people studied God's physical world. That means they studied nature. And physics, chemistry, biology was born out of that investigation. Then there were two talks. The first talk was AI/ML optimization in CERN. Why AI/ML in CERN? The LHC experiment produces about 90 petabyte of data per year, and an additional 25 petabyte of data are produced per year for data from other non-LHC experiments at CERN. LHC is Large Hadron Collider. Archiving the vast quantities of data is an essential function at CERN. So data is an important part of the CERN environment. Data. What to do with the data, how to store it, how to compress it, how to make use of it. So data science, big data, is integral to the functioning of CERN. And how much is 90 petabyte? It is 9 into 10 to the power 16. LHC generates about 1 petabyte of collision data per second. 230,000 processor cores and 15,000 servers run 24/7. So you can imagine the huge amount of computing power they have, and that is needed for their operations with the data. So there was a talk on AI/ML optimization in CERN. A platform called ML Coffee was mentioned. I have not seen what it is. You people should see. ML Coffee, this is a reinforcement learning related platform. And they talked about numerical optimizers and optimal control, machine learning for regression, computer vision, anomaly detection, trending and forecast, reinforcement learning. Anomaly detection, you can intuitively see is relevant. When a new particle arrives, which is what they are after actually, to find out the existence of new particles. So new particles, whenever they arrive, there is a kind of anomalous behavior in the whole system. So ML Coffee is something we should take note of. And then I heard this talk by Oriol Vinayl, who is from DeepMind. He described the success of AlphaFold in protein folding prediction. And the challenge I was mentioning is called Casper challenge. Disruptive performance by AlphaFold. This was a newspaper report. Artificial intelligence has solved one of biology's grand challenges, predicting how proteins fold from a chain of amino acids into 3D shapes that carry out life's tasks. Okay, predicting the 3D shape of proteins. This week, organizers of a protein folding competition announced the achievement by researchers at DeepMind, a UK-based AI company. Oriol also said AI should generate data. Okay, let's note this. All of us are hungry for data. And he mentioned 3 or 4 tools, platforms, I don't know. Again, I have to research on them. Pixel CNN, WaveNet, of course, we have been using. Big GAN and VQVAE. Okay, these systems were mentioned by him for synthesizing data. So to end this particular presentation, we look back at the questions in the beginning of the talk. Artificial general intelligence, you might have noted that many points made, many discussions actually touched upon AGI. And in machine learning parlance, we are familiar with this. Zero-shot learning, approximation adaptation is something we have to take note of seriously. Missing blocks in AI. Okay. What are the missing blocks in AI? Did the whole event throw any light on missing blocks of AI? I think so. I mean, curiosity, creativity is one of the missing blocks in AI. And personally, this is almost a dogma I have. We have to model boredom. Okay, we have to create machines which get bored. And then one of the missing blocks is also the interaction of model-driven AI and data-driven AI. AI and creativity, there was a full breakout session on creativity. Creativity surfaced many times. Ethics, governance, and AI risks. So downside of AI was mentioned by at least 2 speakers. Okay, the fact that robots may not be environment conscious, and therefore their decisions may not be environment sensitive. But one of the speakers also said that more than AI risk, it is climate condition, which is a much more serious risk proposition. What if AI succeeds? If AI succeeds, then machines will share the world with humans. Who will have the control? Ultimate control is a different question. Is reconstruction of personalities and behavior prediction possible? A company showed that this is possible. So you can exploit the footprint, social network footprint, to create personality. And AI for science is big. Okay, ML researchers are deeply investigating the question of how to make use of data and make scientific discoveries. Okay, that's all. Thank you. Okay. So now we can have discussions. I'm
Sir,
sure there are, yeah.
one doubt, sir. What are the general algorithms CERN uses for anomaly detection, sir?
I don't know, because this was a 1 hour talk, but all these are published actually. So all these AI ML optimization algorithms by CERN are published. Yeah. I really don't know the details.
Okay, sure, sir.
Okay. So now let's see the chat box. I think there are a large number of comments, questions. Oh, we have. How much time we have spent? Close to 2 hours. My God. Okay. So now on the chat box, can somebody help me with what is there on the chat box? Who can read them? Large number actually. So Sandhya, why don't you read?
Yes, sir. I'm coming to that. Yes, sir. There was a question from Ritvik. He asked, human beings work on, he's asking whether human beings work on reinforcement learning.
Whether human beings work with reinforcement learning? Yeah, they do. Surely they do. One of the best examples of reinforcement learning in action is any kind of learning that a child does. The way you begin to learn how to write A. If the A is not proper, then mother gives a feedback or teacher gives a feedback. And then next time you write it better.
I meant to ask, sir, whenever we say we don't know how humans learn, can we close this debate by just saying that humans learn by reinforcement learning?
Close this debate, Acha.
Can I put my comment? Yes. I don't think humans totally learn from gaining some sort of award mechanism. We also have two very important things, introspection and retrospection. Like suppose a very classic example, but very gory also. Suppose we don't like someone, we won't directly go to murder them. We will introspect into the situation. We are not directly going to maximize the reward. So I don't think we can close the discussion at reinforcement learning directly.
Okay. Okay, we'll have debate discussions on this going forward. Let's see what other comments are there on the chat box.
Yes, sir. Then there's a question put up by Aditya. Can training loss convergence when a machine learns to be viewed as it's attaining the state of boredom? What other attributes, dimensions of boredom are important?
Aditya, can you elaborate? Aditya, are you there, Aditya?
I can see him.
Yeah, I can also see him, but he's muted. Hello, Aditya. Okay, we can take it up later.
He made some comments, actually. I mean, his voice is not audible, I guess.
Aditya is muted. I see that. Yeah. Okay, let's take the next one. I'll WhatsApp Aditya.
Yeah. Then there are a few comments by him only. He spoke about serendipity, like how it is often cited in recommender system, where the system may not always recommend the item that gets the higher argmax utility, but the system prefers to surprise the users by showing items that they aren't likely expecting. So this is a phenomenon in recommender system. Okay. Then,
this was a comment by him.
Yeah.
Okay. Let's go ahead.
Yeah. Okay. Yeah. Then there are multiple, like some comment by Swaroop as well. Yeah, this is general comment. Then Aditya again mentioned a keynote at ACM Rex's conference last week was about a graph neural network. The speaker showed its applications in chemistry, recommendation systems, and had a discussion on how the transformers are a special case of graph neural networks. This is a comment by Aditya. Yeah.
This is by Anima Anand Kumar, I think. Yeah.
Yeah. Then Pankaj made a comment about protein folding competition happens every 2 years. Okay.
Achha.
DeepMind pushed SOTA by a large margin from 18 and then beat their own score in 2028. This is an observation made by Pankaj.
Yeah, this was mentioned.
Yeah. Then Swaroop shared a GitHub link. Achha, he's sharing a work, how a cortical neutron is similar to deep neural networks. Okay. Then okay, so Tejpal is asking how can modeling boredom can help?
How modeling boredom can help?
Yeah, and can it help an AI solution evolve? The question by Swaroop.
So just wanted to know, like, I mean, why the emphasis on boredom? I mean, why you came up with that idea, and how it can help? I mean,
yeah.
Sir, 1 minute. Sir, in the same line, Aditya has also put up a question that how does computational boredom manifest in NLP problems? So they are like related to the similar topic.
Yeah. So in NLP problems, there is this push for dialogue systems which can produce diverse answers. Okay, not the same response every time the same situation happens. So if a chatbot has to greet you, it need not always say hello. Sometimes it will say good morning, depending on the time. Sometimes how are you, and so on. So NLP boredom is quite easy to spot. You know, you speak the same thing in same situation all the time. And chatbots are required to have variety now in their conversations. And why boredom research is important? So boredom, if boredom is modeled, then this will automatically trigger learning. Okay, so when we spot that we are in a situation which is not changing at all,